So hello, welcome back my friends. Today we are going to talk about the descent forecast page and basically what is descent forecast page, why we are using in real life and the descent forecast page, and be aware of the fact that the descent forecast page it's very crucial and important part of your flying. Okay, um, all the descent planning in Boeing, it's really a complicated mathematical method how to do it, but I will try to make it very simple, but really very simple. Okay, so I will tell you what is important and what is not important, what we should do and what we shouldn't do. But before we start our explanation, we should have to make the things in the proper way. So we have two types of VNAV, and it's hard to showing you on flight simulator because the Zibo and PMDG are completely different. Okay, and they have some bugs which I can see right now, but anyway, if you look let's say here, you have basic and common VNAV. What does it mean? What is the difference between basic and common VNAV? The basic VNAV means that you have no longer on descent page this path. Okay, you have just econ descent or descent. If you don't put the cost index, for example 0, you have just descent. Okay, and this command VNAV, which is right here, may deviate if there is a significant change in your VNAV path, so significant weather change during your descent or something like that. It may reverse to VNAV speed from VNAV path to VNAV speed. But if you have basic, he will strictly adhere to computed path. And how it is looked like? Okay, it looks like that you have top of descent point. From top of descent point you can come to, for example, speed limitation point, then you can descend to deceleration point, from deceleration point to the point so called end of descent, and which means the missed approach point or the runway itself. Okay, so this is just how it looks like. But what is the difference between Zibo and PMDG? Zibo is using the model which is right now a little bit, I guess a little bit older, because nowadays the most of the airports establish the green descents and CDFA technique. You know all what is it. It means that you have to constantly make at least 500 feet per minute descent. Okay, and you shouldn't level the airplane unless the low visibility procedures are in force. Okay, so the Zibo, when there are two altitude constraints and there are no idle descent before this constraint, the Zibo will be level up, come to intermediate top of descent, which is depicted with the green, and from this intermediate top of descent he will start the idle descent again. If you look at the PMDG between these two waypoints, he will adjust the thrust settings and keep the VNAV path with the higher thrust setting. Okay, so it will not be idle descent, but he will descend. Okay, so this is the let's say very simple set which types of VNAV we should have on the board, and now we can come into our famous page, so that means forecast page, and now you can see we have bunch of information. Okay, so now I will start with the transition flight level. Why is it important to put the transition flight level? The transition flight level is very important to put there because standard procedure on Boeing is when you are in flight level and you have cleared to exact altitude and you don't press the from standard to QNH, the transition level which makes the layer between transition altitude and transition flight level, that means that that there is no separation layer between departure and arriving traffic. It shows the yellow box if you overshoot the transition flight level and tells you, hey man, you have to revert to QNH. Okay, so this is the purpose of transition level. Okay, and now I will go to the very important thing, and this is this thing. Okay, here you can put it into two ways, via ACARS, which is on PMDG, or let's say just go to your operational flight plan, and from operational flight plan, as you can see, for example, we have we can put descent flight level 300, so 17452. Always it is with descent. Okay, so and now we can put, for example, flight level 200 and 100. So let's make it interpolation because we have to be precise here. Okay, as much as we are precise, the better conditions we have. Okay, or let's say I will write a sentence over there. This is the official Boeing statement. Don't laugh, it's true. Okay, 184.20. So 184 and 20. Okay, like this one. And now the last is flight level 100, 250.12. And now what happens if we have a strong headwind component which is not incorporated here, or we'll leave it blank. We are constantly have FMC speed and we are pushing the airplane to catch the VNAV path. Okay, so it will be no more idle descent and we are going to burn the fuel, and we are professional pilots, so we don't want to do that. Okay, if for example is another situation like we have a strong tailwind component as we don't expect, we will be high on the profile and we will constantly need to use the speed brakes in order to catch the glide slope, and he is shaking with the airplanes. It's uncomfortable for the passengers. So this is very important. This is important for reminder that okay, you are now here, and that's okay. And transition flight level, it's one more thing. It's very important for your calculation, and it has integration with QNH. I show you on the picture above. Okay, so and now go to Tango Alpha India, so TAE on off. What does it mean? If you look at the significant weather chart, you can see that we have from flight level 130, which is our starting of engine anti-ice. That means that from this flight level we can encounter moderate icing, and if you look at the weather chart, you can see from the weather chart, I will need to scroll down, you have it right now on the computer, it's broken 4,000 feet, okay? Why we don't put there flight level 100? XXX means that it's up to that this significant chart is valid for flight level 410 to flight level 100, and below flight 100 there is nothing depicted, but as you can see we have broken at 4,000 feet, so that means that we should put slash and 4,000 feet, and this is where we put engine anti-ice off. If we do not do this, and this is very important, the FNC will calculate without using engine anti-ice, okay? Because if you are using engine anti-ice, for example, you are on the top of descent, okay? And you start the descent. What happens? Okay, it will go to, if you are precise, it will go to idle thrust, okay? So that means into the thrust, which is, for example, idle, it's computed by EEC, engine electronic control unit. Input into the engine electronic control unit, which is basically FEDEC, has the environmental conditions. So in case of these environmental conditions, he will put the idle. For example, N1 idle will be 38% of N1. But if you put the engine anti-ice on, in order to avoid the flame out, he will raise the N1 up to, for example, 40% N1, or 45 or 48. It depends on the conditions. In classics, some older classics has a placard here, when using engine anti-ice, keep at least 40% N2. So that means that if you are descending and you don't have you have for example idle descent and you use the engine anti-ice, you may have the flame out, so that means that you have to adjust the thrust manually by yourself. But this is old style and really old classics, okay? Now we can avoid it, so we have FEDEC, everything is okay. Or let's say EEC, engine electronic control unit, which is dual channel. And now we have ISA deviation. What does it mean, ISA deviation? Okay, ISA deviation means that, for example, it's average deviation from temperature, which should be during your descent, but most of the pilots are making ISA deviation within the airport, because of this column, and only this column you can obey, because it has negligible effect, as you can see on the picture above, okay? But if we are precise and we are accounting with standard atmosphere model, that means that we don't account with environmental lapse rate and isothermal inversion layer, but adiabatic lapse rate, which is the forecast model. It means that roughly 2 degrees per 1000 feet of altitude. In case Tromso, which are we going to fly, it's on the sea level. That means that in ideal condition, in international standard atmosphere, you should have 15 degrees of centigrade. And now if you look at the chart, look at the OFP and whether the Tromso has 8 degrees of centigrade. What does it mean? That 15 minus 8 is 7. So I will put minus 7 over here. Okay? Sometimes when I click over here and it doesn't work, it's because it's improper modeled. Okay? In a real airplane it looks different. Okay? But anyway, and now we are at the point which is really important, and this point is QNH. Okay, the QNH is important. I can show the picture above. This is the very rough and very simple picture how it is calculated. Okay, if you do not put the QNH right over there, all the computations to the ground will be computed by QNH 1013 by FMC. But if you put the lower QNH, okay, that means that when you press standard, okay, you will have your VNAV path will be suddenly below, and you have to catch it. Okay, and if the QNH is too high, for example 1024 and 1030, and then you press the QNH, okay, suddenly your VNAV drops and you are high above the profile. So that's why it's very important to put the QNH over there. But in Tromso we have right now the QNH of 999. So that means that I will just pre-select it, but we will not put it there. Okay, and as well I will get rid of this one. Okay, and just let you know. So this was the basic explanation of descent forecast page and how it is important for your flight planning. Okay, if somebody wish to know more about this, I can send you I can make a photo or let's say scan from my technical book, and it's a really hard mathematical method, and it's really hard to understand how it works. Okay, with all the constraints, speed constraints, altitude constraints, and so on and so on. But we as a pilot should know all the things what I have told you right now. It is the basic things. Okay, but anyway, we are diving to Mosul. I will check it right now, and from Mosul we can go to, for example, Atvek point, and before the Atvek we can make some waypoint. Okay, but anyway, I will put the arrival page. Okay, it's ILS runway 18, Atvek 1 Mike, and via this point it's and so okay guys, now we are on the cruise, and we are currently going to the top of descent point, which I would like to point out. And as you can see, we are directly going to Tromso airport via Advek point, and Advek point has altitude restriction 6000 at or above, so that means that we will be higher on the profile. Okay, if I delete this restriction, put it like this one, as you can see we have flight level 273. Okay, but I will erase it, and let's say imagine that I would like to have overhead Advik point, for example, flight level 200, okay? So that means the top of descent will be closer to us, okay? Or 150. Okay, so Advik flight level 150, okay? Because I would like to show the intermediate point and what is the difference between intermediate point and geometrical descent, okay? And that's why I choose the Zibo right now. Again, I'm talking about that I'm not preferring any platforms. I'm not fan of svveral, I'm not fan of X-plane. I will do it what I feel the best is in reality, okay? Okay, another point is, go back to the cockpit. Always start to descend 20 nautical miles prior the top of the descent. Why? Because there could be some changes with the ENTC, for example, block runway. You should have use another runway, or let's say wind conditions significantly change. They swap the runway, and can you give another star? And now you are high above the profile. So this ensures that everything is going okay. So we have ATVEC and we have altitude constraints flight level 150, okay? But as you can see from ATVEC, we have 20 nautical miles to Ulnik and 22 nautical miles to Nornu, which is clearance limit point. So and there are nothing depicted over there that there are any constraints. Everything is 5,000 feet, okay? 5,000, 5,000 and 5,000. So we should have the intermediate top of descent point, okay? So I'll show you how it looks like. And as I said before, I will put descent forecast page without engine anti-ice. We should refill it via significant weather chart and without the QNH, okay? And if it is pre-sized, the wind condition and the flight simulator comparing to real life, we should have good results, okay? Or let's say results what I expected, okay? Okay, and I put no minimums right over here because we are fully visually, okay? Or let's say we are in VMC because of broken cloud 6000 or 4000, I guess so. Let me check it. Descent forecast. I will delete it from there, but anyway, I will check it right here on on operational flight plan, and yeah, we have 4000, so that's okay. That's about our MSA, but MSA is 7100. Okay, so yeah, basically we have to put the minimums, okay, right over here. But for this purpose, I will skip it, okay? Or okay, just for you. Okay, again, we have to meet the climb gradient 4%, 3 to 2. Okay, now it is okay. And remember, if you start to climb before the top of the descent, Boeing recommended is use two methods. One method is via vertical speed and put 1000 feet per minute, okay, and always watch the speed, because it can because if you are on the vertical speed, he will have the priority of vertical speed, and he doesn't care about the airspeed, okay. Another thing is it's maybe a better solution, go to descent and descent now. If you press the descent now, I will show you later on, he will keep the 1000 feet per minute, okay. And FMC in a scratchpad message, if you are close to the top of descent, I guess it was 10 nautical miles, but it was the engines I flew in real life, but here in Flight Simulator it is 5 nautical miles, and I'm not fully aware if I'm wrong or if I'm okay. But anyway, somewhere between 10 and 5 nautical miles before the top of descent, you should have a warning message right over here and scratchpad message, okay. So that means that alert you, I may go down. So, well, basically we are flying to Tromsø Airport. Tromsø Airport, it's category C airport because it has steep descent angle and unpredictable weather conditions, so that's why. And short runway, quite short runway. Okay, so now we are close to the top of descent point. If we don't have the intermediate top of descent, that means that something is wrong. But if you put in the flight plan page and put it on the legs page, we can go here and this is the deceleration point. Okay, so that's why we have to decelerate, okay, with the flaps, and this is the end of descent point. Okay, but we should have intermediate point. We should have, but flight simulators are so buggy comparing to a real airplane that yeah, well, but what else we can do? As you can see, we are 10 nautical miles, so this is modeled by 5 nautical miles. So if you are somewhere over here, we can put the descent now, and as you can see, it will constantly keeping 1000. Okay, we have a message that's okay. Descent now. Okay, sorry, I need to revert. 120, descent now, and right now it will start to descend. Okay, and what we will do? It's again if you have basic or common VNAV. Okay. Okay, now he's closing to the flight path. VNAV, so he will retard arm position. That's okay. That means that the thrust levers are fully closed, and we are all okay and good to go. And now I will show you how we can modify it where we are descent. Okay, so now we have currently 41% of N1. If I put the engine anti-ice into on position, okay, this changes, and as you can, 41 is going to 42. It's not big deal right now, okay, because EEC calculates that it's okay, so we are basically still on the flight path, but in certain conditions it will rise up. Okay, so we'll put the anti-ice off, and now for example air traffic controller give us, for example, speed 280. What does it mean? /280, we put it here, and now you can see if we are slower airspeed, we have to use the speed brakes. Okay, as we catch again the VNAV path. But as you can see, come on, VNAV path. Now because we have reached, okay, but anyway, okay, so we have VNAV path. And now for example this is not econ descent. Econ descent is always put when you are keeping the cost index by your company. So if we have, for example, speed 230 like this now, okay, okay, we are still below. But if we put flight level, speed 320, like this one, we are high above the profile. The basic idea is because we have with higher speed the steeper angle is, the lower speed the shallow descent is. Okay, so I will revert it into the econ mode. Okay, now we have the econ mode. And as you can see, we are again on the arm mode. So once again we are okay. We put the engine anti-ice again, and from 380 it will rise to 40. It depends on the conditions. Okay, and sometimes it could happen that he will rise to 48 and you are high above the profile. Okay, because your idle rivers are not so low, but your idle rivers are really really high, so that means that you are high on the profile. But in this case it basically makes nothing changes because there are only 1%. Okay, so it's okay. Maybe at the end of the video I will put another video. I will make it split into 2 parts, and we can make it with the PMDG. Okay, so this is the reason why we put in the forecast page when we are switching engine anti-ice on and off. In real life it really matters. Okay, so now we are approaching to Arctic point and we have flight level 150. If ATC wants you, for example, 120, we can put 120. But what happened? We will be higher on the profile. Okay, as you can see, we are higher on the profile. So there are 2 methods. Using the speed brakes, and we will see how the airplane will decelerate. If we don't decelerate, we have to adjust the speed manually and put a higher speed in order to meet the requirement over this point. Okay, so now if you watch, we have speed brakes up position. Another point of view is the deflection of the speed brakes, because they are varied from option to options, but anyway, it's okay. And now you can see that we are entering clouds at flight level 130, what was depicted on the significant wind chart. Okay, so now we are okay. We can stop the speed brakes. And we can put 5000 feet because it is our clearance limit point, as you can see right now on the chart. Okay, we can go down to 5000. But as you can see, what is the airplane doing? He's keeping the constant level flight. Why? Because of this one. Okay? And this is the intermediate top of descent point with flight level 1 to 0, and this is something which is let's say different from PMDG, because PMDG doesn't show you intermediate top of descent. It will make it like constant descent with some thrust additional, okay, but the Zibo mode will level up, and from this point into Nornu point he will put the idle thrust. So you have to choose whatever you like. You like Zibo mode and with the intermediate top of descent and level the airplane, or you like the PMDG with the descent which is basically constantly and geometrically path descent. Okay, and now, for example, as an example, and that's why I don't put there on the descent forecast page. Now, engine anti-ice, we have explained it. Okay, it's important in real life, because if you put engine anti-ice, your idle N1 will be rising, you will be higher on the profile. That's why we are putting here. Okay, but let's say we are clear to flight level 5000 feet. Okay, so I will put 5000, 1000 per minute. Okay, so I will in this case disregard the intermediate position. Okay, and let's make it but I will delete it from this. Yes, so we have high speed approved anyway, 1000. Okay, and as we have turbulence to 80, and now we have flight level 100, which is our transition flight level. Okay, so anyway, if we disregard this one and we are going in certain point below flight level 100, it should appear the black box, yellow box right over here, that we have to switch. Okay, so we are approaching flight level 100, and as you can see, the yellow box is a warning for us that hey, you are in altitude, not in standard mode, so put it like press QNH, okay? So guys, we are on Palma de Mallorca, we are currently on the standard and descending to 4,500 feet, okay? With the standard, okay? And we have proper QNH 1022, so press standard, okay, everything is okay, everything is quiet and everything is okay. But if I delete this, or let's say put 1013 because it doesn't delete, you can see we are quite below the profile. If I put there on the QNH 1024 will be high on the, or no, 1024 because we have actual 1022. 1040 we are high above the profile, okay? So this is the reason why to put the proper QNH right over here, because if you press standard you'll be low on higher on profile, okay? So if I put 999er will be low on profile, okay? As you can see right now we are low on profile, but if I press exactly QNH, what is there, the profile should be the same, okay? But it's flight simulator, okay? So this is the purpose why we are doing this way. And if we are coming to the airport, or let's say approaching the airport, so we are in approach phase, and we will make any change into the QNH like this one, so you can see it's always changing our altitude. So that means that our Baro VNAV, it's basically related to our current altimeter setting. That's why it's very important for non-precision approach and APV Baro approach, okay? Yeah, you may obey it with ILS precision approach because it's physically done, okay? But this is true, and this is the procedure, and this is the forecast page would like to point you, okay? So again, thank you for the watching, and I hope my video will be enough for you. And if you don't understand something, leave me a comment and I will explain it to you, okay? So have a nice day, bye.